calculus yet. Okay, is that all right? How we rewrote it?
Yeah, that makes sense.
Now it's the same thing as the previous problem. We're using this common derivative on the right where it's a number c times x to the n. You bring the exponent down. So it's -6 times 4x, and then you subtract 1 from the exponent. You bring the exponent down times -2, x to the -1 minus 1. So this simplifies to -24x to the -7, +2 x to the -2. You will eventually be able to go right to this line here. You know, -6 times 4 is -24. Subtract 1 from the exponent. -1 times -2 is +2. Subtract 1 from the exponent. That is your final answer. Any questions on that?
No, not so far.
Okay. Number 3 here. So the other types of things that you can do to rewrite this are to not just use exponent rules, but to actually perform some sort of algebra. So you can divide each of these by the x. And so the rewrite here is that it's x to the 5th over x, 12 over x, like that. The rule when you have an x to the n over x to the m is that you subtract the exponents. So this becomes x to the 4th. And then this one is the one we used in the previous problem. It becomes 12x to the -1 power.
Okay.
No derivative yet. We have yet to take a derivative. These are just rewrites. Now to take a derivative, you bring the exponent out in front. So this is 4x to the 4 minus 1 power.
Okay.
Plus, bring the exponent down and subtract 1. So this becomes 4x cubed minus 12x to the -2 power.
And do you think the best way to memorize these rules are just by doing example problems and using them?
Yeah.
Okay.
Remember, your test is going to be most likely questions like this. And I've
Okay.
heard that sometimes it's multiple choice. You'll know more, I guess, when you go, because that does change how I teach this to you or help you with this, because I
Okay.
want you to get through the class, obviously. So like fill in the blanks require you to do it by hand. You can do a little bit with multiple choice that you can't do here. Have you looked ahead to see if you get a test or an exam review?
Um, I can't remember off the top of my head, but I did look the other day.
Okay. You might even throw out an
Yes,
email to
there,
your
yeah, there's a
instructor.
midterm review and then a final review.
Okay, maybe you go also email your instructor, ask, hey, is the midterm and final, are they multiple choice, free response? What are they? Hopefully they'll
Yeah,
tell you.
hopefully.
Yeah,
Hopefully they're multiple choice. So.
you never know. You never know. People are. All right. Just make sure I haven't skipped any. Always, make sure this is the
Yeah.
next one here because I did not grab the problem number. So, first thing here is the tangent line always requires two things. It requires a slope, which comes from the derivative, which means we're going to take the derivative of this thing. And second, you need a point. Talk about that in a moment. So the derivative of this, you're always bringing the exponent down. So it's 4x cubed. Okay. Bring the 4 out in front. There's really a 1 there. For the next one, it's the 2 down. 2 times -17 is -34x. We've not looked at this one here, but the derivative of a constant is, let's snip this in here. Derivative of a constant is 0. So the derivative of this 16 by itself with no x is 0.
Okay.
All right. Now, the slope of the tangent line, that means to put the x value into the equation. So you're going to evaluate the derivative at 2. So it's like putting 2 in for x, 4 times 2 cubed minus 34 times 2. And so we will need to simplify that. If you have a calculator, please double check that.
Okay, yeah.
All right. Now the equation of the tangent line, the tangent line requires a slope, which we have now. That's the slope, and then a point. You have the x value. So you have your x value here. To get your y value, you have to put 2 back into the original. So it's literally a point on the curve.
Okay.
So I'm going to calculate that. Let's see here. All right, and that is also minus 36. Huh. That's weird. Why would they be the same? 832. All right, let me just quickly check something else here. We're good on that. So you have a slope of minus 36 and a point 2 comma minus 36. And it does not specify the equation of the line. So you can actually put it in any form. The best form is what's called point slope form, because you don't have to do any work. You've already got it. It's y minus y1 equals m x minus x1. So you have a slope and you have an x and a y, or an x1 and a y1. So you just put these into the equation.
So it'd just be y plus 36 equals negative 36. Okay.
Yep. It doesn't specify the form, so you're good with whatever you choose to do.
Okay.
All right. Next question here. All right, find all points on the graph where the slope of the tangent line is 0. So what this is requiring you to do is to determine the derivative. And then you're going to set the derivative equal to 0. So we have to take the derivative of this here. So the derivative is the same rule we've been using. You bring the exponent down, 2 times 6, that's 12, x minus the derivative of a number times x is just a number. That's your derivative. The derivative of 14, which is a constant, is just 0.
Okay.
And now you set it equal to 0, and you solve for x. All right, so this ends up being x equals 25 over 12.
Okay.
And that's not the answer. That says they always help you here in Pierce. They say type an ordered pair. So that's the x value. To get the y value, you have to put 25 over 12 back into the original function. So just do the best you can with this. I know it's not ideal, but can definitely help if you have questions about how to use the calculator to convert to a fraction, or how to deal with the fraction. But
I still
this
don't have
one,
my calculator yet. It's at home.
okay. All right, so this ends up being minus 289 over 24.
Okay.
I threw in the chat the link to the Desmos scientific calculator if you want to use that today. But this is, so the answer is, or the 25 over 12 comma minus 289 over 24, which I know doesn't look great, but that's what it is.
Okay.
All right, that's let's move on here to the next one. All right. All right, so on your on that reference sheet I sent you, there is a bunch of derivative rules, and at first it just looks overwhelming. I mean,
Mhm.
there's just a ton there. If this were introduced in a classroom, you would spend probably a full 2 or 3 days on what we just did, and 20 minutes. But the product rule is when you have a product, like this is a product of F and V, where F is the first thing and V is the second thing. So you got a product here that you're multiplying together. Will you attempt to find the derivative of each of these based on what we've been doing?
Yes. The first one for F, would it just be 8x to the first power?
8x, yep.
Or just, yeah, 8x.
How about the second one?
And then the second one would just be 5, right?
Good, very good, yeah. All right, so the derivative rule says when it's a product like this F and G, and it's written over here, but they use this function notation, which isn't all that helpful. It's F times G prime plus F prime times G. And what you're essentially doing is taking these and you're multiplying them diagonally.
Okay.
So it looks more complicated than it actually is, because you just take F is 4x squared plus 3 times G prime, which is 5 plus. So that's the first two. This is F, this is G prime, plus F prime, which is 8x, V, which is 5x minus 4, like that.
Okay.
And yes, you leave your answer just like this.
Okay, you don't have to.
You don't have to for this. Now, if it were multiple choice, we'll talk about maybe what to do. We'll know more. That's yeah, but this, you can leave it like this. I put everything in parentheses just to kind of make it easier to see visually, that where the pieces are.
I can type it in parentheses though, right?
Yes, yes.
Okay. Right.
All right. Next one is similar. So this one says to use the product rule to find the derivative of the function, and you look at this and be like, well, there's no product. There's a component. So that's where it says hint, write the quantity as a product. Uh, that means to write it out as two separate binomials like this. All right, so now there is an f and there is a g. F is 8x plus 1. G is 8x plus 1. Will you calculate f prime and g prime for us, please?
It'd just be 8 for both.
Yes,
Okay.
exactly. All right, so the rule for the derivative, and again, it's f times g prime plus f prime times g. You'll occasionally see these flipped in reference sheets. It doesn't really matter. You're pairing up an original with a derivative and an original with the derivative. So this is 8x plus 1 times 8 plus 8 times 8x plus 1. The order doesn't matter when you're multiplying.
Those ones are pretty easy. Yeah.
I like hearing that.
Yeah.
All right.
They definitely look a lot more intimidating than they are.
Okay, the next one here is what's called quotient rule. That is on your reference sheet here. I'm just snipping it in case you ever wonder where I'm getting stuff. This has a top and a bottom. It's just like before. You have an F, you have a G, and you have to find the derivative of each. So I'll ask you again here to jump in. Whenever you get caught up here, what is the derivative of F? What is the derivative of G?
The derivative of f is 6,
Okay,
and then the derivative of g is 7.
good. So we've now got a little different formula for the quotient rule. This is harder to remember. This is a good question to ask your instructor is if you can bring in a reference sheet to the exam. They'll probably tell you no, but you could ask because maybe they'll tell you yes, or maybe you bring one in and you just sort of like, hope that they don't notice. These are
Yeah.
all things I recommend. You know, up to
Okay.
you. Now, the formula's bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared.
Okay.
So it's kind of the products again, but it's not exactly. The order definitely matters here. So it's 7 on the top, 6x minus 1. Nope, that's completely wrong. Wow, I really messed that up. Uh, whoops. All right, so G is 7x plus 4, f prime is 6 minus 6x minus 1 times 7 over 7x plus 4 squared. All right, and so this is your answer. You do not have to simplify. Any questions, thoughts on that?
Not so far.
Okay. Um, like ideally you would get a lot more practice on these, and that's where maybe you go in and look at the homeworks and work on a few of those, or
Mhm.
maybe watch the video. But the the challenge here is just being able to know the rules, apply the rules, things like that. So in this problem, they're telling you h of x is f of x over g of x. So this is a pure quotient rule problem. Like this is exactly the definition of the quotient rule. So let me snip that in. So the derivative of this, that is exactly what we just did. It's the bottom bottom times root of the top minus the top times root of the bottom squared. But they want the derivative evaluated at 6. X equals 6. So now you're going to put in a 6 wherever you see an X.
Okay.
Okay, now you've got to go back and find each of these values. Like, what is f prime of 6? What is g of 6? F of 6, g prime of 6, g of 6. And they're all up here. They're all given.
Okay.
So
So,
f prime of 6 is 7.
okay.
G of 6 is, sorry for the scrolling, 8. Actually, let me look at that on my other screen. That'll be easier than all the scrolling.
Okay.
F of 6 is 4. G prime of 6 is 3. G of 6 is 7. Yeah, squared like that.
Okay.
All right. So you do have to simplify this. We got 56 minus 12 over 49, 44 over 49. Like that. That's your answer.
Okay.
What about that do you think would be difficult to do?
Just I feel like the hardest part would be if I didn't have a reference sheet, the formula, obviously.
Okay.
But I think when it's given, it's just about like keeping it organized so that you don't put in the wrong.
Yes.
Yeah.
So, millions of students have done this before. You can absolutely figure this out and you will absolutely, but I mean, if you can get a reference sheet, that's even better. You know,
Okay.
we hope for that.
Yeah.
So the next couple of problems are what are called chain rule problems. Uh, but they give you kind of a non-calculus question to start. This is actually something you would see in a previous course, from like a college algebra. This is just a composition. And you always start with the inside function. So the inside function is f of 2. You have to first figure out f of 2. F of x is given as x squared minus 3. So you're putting 2 in for x and then simplifying. So composition is like nesting. You have like one function inside another. You start with the inside one and work your way out. So this ends up being 1. And so the output of 1 becomes the input in the other. Output of 1 becomes the input. G of x is 4x minus 1. You're going to find g of 1. The output of the inside becomes the input of the outside. Ends up being 3.
Okay. And so that would just be the answer.
Yes.
Okay. That does seem a lot like algebra.
All right. That is the final answer there.
Okay.
All right. That's not a calculus question. I doubt you'll get that on your test, but
Okay.
I can't do it. Can't. All right. Find the derivative of the function. So, totally new problem here. These are all now what are called chain rule problems. Chain rule is the composition of other rules. So the issue here is that there's nothing on your sheet that shows you how to take a derivative of something like this. Okay. So I'm going to help in this first problem is we're going to rewrite it here. K of u equals minus 9 u to the minus 6 power, where u is 12x squared plus 5. Okay. And this right here that I've rewritten, we do know how to take the derivative of. Okay. This is a power rule derivative. It's like we were doing early on in our lesson today. You take the exponent, you multiply by the number in front, subtract 1, Hopefully that looks familiar. This becomes 54u to the minus 7 power. But there's one little addition, one little wrinkle to this problem. You have to multiply by the derivative.
Okay.
And you're like, what is this u prime? Well, u prime represents the thing that you kind of were holding off to the side here.
Okay.
It more generally, it's the inside function. So u prime here, you have to be able to take a derivative of this. Derivative of this is 24x. Okay, and now you're just substituting back in. You're like, okay, my u, that's my u, and that's my u prime. You end up substituting back in. It's called a back substitution. So 54, 12x squared plus 5 to the minus 7 power times 24x.
Okay.
That is your final answer.
Okay. So you also don't have to work out the first part like
You
54.
just keep it as is. Yeah. You know, now on your, again, if it's multiple choice, we'll talk about like how it might be rewritten. We, I, I will offer some options if and when we know that.
Okay.
All right. So, a lot of times students ask me, well, how do I know what U is? You know, what to make U for the chain rule? Well, there's some options. It's usually in parentheses. It's usually an exponent. It's sometimes in the denominator. It's maybe under a root. These are just guidelines.
Okay.
There's no like 100% sure way of doing it, but I'll do my best to try to explain.
Okay.
All right. So I've got a new problem up here. Guess we're getting close to the end here. That's good. Were you planning on this taking 2 lessons, or do you have something else for us for tomorrow?
I have something else for
Oh,
tomorrow.
good, because we're gonna finish this and
Okay.
good. So there's a small rewrite here to do. -4 parentheses 7x to the 5th plus 1 to the minus 6 power. And now it looks a lot like what we were just doing. The previous problem. Previous problem had basically the same structure. Some number out in front, something in parentheses to a negative exponent. Could be a positive exponent. So we're going to rewrite this as y equals -4u to the minus 6, where u is 7x to the 5th plus 1.
Okay.
Do you hear the cat purring or meowing?
Yeah.
Okay. She's hungry. She's eaten all day. All right. So the derivative here is power rule again. So you bring the -6 down in front, -6 times -4, 24u, and then you subtract 1 from the exponent. Because it's a chain rule problem, you multiply by the derivative, u prime.
So you plug in the
U, and then we have to find u prime. So what is u
oh
prime over here to the right? Yeah,
so would it be 35 x to the 4th?
good.
Okay.
Very good. So these are substituted in. So it's 24, your u is 7x to the 5th plus 1 to the minus 7 power times 35x to the 4th, like this. This is your final answer.
Okay.
Any questions, thoughts on that?
No, just something I need to practice so I don't get the u prime mixed up.
Yeah.
I think that's my biggest issue.
Okay. Find the equation of the tangent line. So again, for the tangent line, we need two things. We need the derivative, which gives you the slope, and then you need a point. So the derivative of this is a little bit more complicated than what we've been doing. The derivative is going to be, again, a chain rule. So this is square root of u, where u is x squared plus 11. This is really u to the 1/2 power. So that's another little thing from your previous courses that you have to remember. The reason is there's really a 1 above the u and a 2, which is called the index, which is, fairly useless information, but you need to be able to rewrite anything to a root as a number to an exponent.
Okay.
Just have to be able to do that. All right. So your derivative is 1/2 u to the 1/2 minus 1. This is where a lot of students they get stuck here. You have to remember how to subtract one. If you got a calculator, great. Let it do the work. And then you always multiply by what's called the derivative of the inside function. That's the chain rule part.
Okay.
And that's textbook. Like I didn't make up the word. That's just what it's called. I don't really know
Okay.
why it's called that, but all right. So we need the u prime. U prime is just 2x this time. Now you substitute these back in. So it's 1/2 x squared plus 11 to the minus 1/2 power times 2x. Now, sometimes it's worth rewriting this when you are going to use the derivative, and that is the case here. So this is 1/2 2x, and then it's x squared plus 11 to the 1/2 power. And you can see now that the 2's are going to cancel. And the 1/2 power is rewritten as a square root, like this. So like in a multiple choice situation scenario, that's where this would come into play. Like this would be your answer for the derivative. Like it wouldn't look like this on the left. This is
Okay.
what you would see on a multiple choice. And
Okay.
that's where you have to be able to make that change. So we've kind of done part one. We've got the derivative. We need to evaluate the derivative at this point at 5. So we need to put 5 in for x. So f prime of x is x over square root of x squared plus 11. F prime of 5 equals 5 over square root 5 squared plus 11, which ends up being over square root of 36, which is 5 over 6. So that's thing one.
Okay.
Thing two is we need a point. So to get the point, you go back to the original function and you evaluate at 5. So you have to put 5 in for x. Ends up being 6. So your ordered pair is 5, 6, and this is your slope.
Okay.
So we did in an earlier problem, we used point slope form. We'll use slope intercept form in this one, just so you have an example of each in your notes there. That's y equals mx plus b. You have your slope. Your slope is 5 over 6. So it's y equals 5 over 6x plus b. And then you use this point as an x and a y to solve for b. So that's 6 equals 5 over 6 times 5 plus b like that. Fortunately, this does not work out nicely, which I'm really surprised at, but that is the case. Okay. So this is 6 over 1 equals 25 over 6 plus b. The fraction on the left can be changed to 36 over 6 if you multiply the top and the bottom by 6.
Okay.
And then the reason you do that is because you want to subtract the 25 over 6 to the other side, or you let your calculator do that. What am I thinking? You're gonna have a calculator. That's silly. Equals b. So B is 11 over 6. That goes back into your original equation up here. So the answer is y equals 5 over 6x plus 11 over 6. Just this part, though, is what goes into the thing there. Right, and that does work. I just checked it graphically. Just to be clear, what a tangent line is it hits the curve at a tangent. So it made a quick sketch of this. The green is your original, purple is that line we just graphed, and you can see this little place here. That's where it touches. It's tangentially there.
Okay. All right.
Is that everything from this one? Did we get them all?
Yes. Two were wrong.
Oh no.
Um,
So double check how you entered them. That's a possibility. I don't know. There's many other things. If you want, I can look at them, see what the issue is.
okay. Um, so for number 9, that was the one where you substitute it was the f(6) one, if you remember or where 6 was.
Why am I not finding it?
I can screen share with you, actually, that might be easier.
6 here.
Yes, that one, yeah. And I put in 44 over 49, and it says it's 11 over 16.
You have 6. Oh, yeah, I grabbed the wrong number. That was 8. Sorry
Um,
about that.
that's okay.
Yeah, that does reduce to 22 over 32 and 11 over 16.
Okay. And then the other one that was wrong was number 8. And it was the quotient rule one, 6x minus 1 over 7x plus 4. And they multiplied up the top to
They
31,
did.
I think it was, because it was
Okay.
31 over 7x plus 4 squared. But
Okay. So you might consider simplifying it. Um,
I just don't see how there wasn't an x at the top.
it does simplify, and the X thing does cancel.
Okay.
Um, so like, in full disclosure, there's a million calculators out there that you can go and, ask for the derivative of this, and it will simplify it. It just doesn't help you when you've got to do it on your own. Um, so
Okay.
and it didn't, I mean, I'm looking for it just to simplify your answer. See how this one says to simplify your answer.
Yeah.
Um, maybe you could email your teacher if you wanted that extra question correct on this. I don't know, tell you that's probably why they give you 3 attempts. They're saying, hey, you can go back and do it again if you want. But
Yeah. Yeah, but then
all
that
right.
is kind of annoying because I always look for that too, what it says after the answer to see what it kind of wants in the blank box.
Right. So
Okay.
I guess we can stop there for today. Let you get something like 2-minute question.
I think that was it of the questions I had. I think
Okay.
I just need to work more on